Maybe I'll play some Return to Castle Wolfenstein. Perfect. You've probably heard of Return to Castle Wolfenstein, or at least Quake 3, whose engine it's based on. Released in 2001, now 25 years later, I get a message from someone saying it crashes when they try and launch it. And they're not wrong. There's a lot that can change in 25 years, but I'm a firm believer that people should always be able to play their old games. Sure, there's fan ports and updates, but let's try and fix this issue and maybe even a bonus bug? So what we've already seen is the game crashing when it's launched, but that was in a VM. It works perfectly fine on my host machine. The message I got said that they were running on an integrated graphics card, and whilst my VM is a strictly worst graphics experience, I'm hoping that it's at least representative. Just running under a debugger and we can see the crash. Exception access violation. So we're accessing memory the process doesn't have permission to access. The address in question looks a lot like ASCII. Colour me intrigued. The game files have a GL directory with some OpenGL-esque libraries inside, so that's probably the graphics API we're looking at. Normally I'd use a tool called RenderDoc for debugging OpenGL programs, but this version will be far too old. Instead, we can use a tool called API Trace, which does handle older API versions. And if we run it through that, we can see it makes just two calls to GL get integer v before crashing. This function just returns integral data from the OpenGL state machine. It's unlikely to be the cause of the crash, but it's a breadcrumb we can hopefully follow. Using Ghidra, an open source decompiler, we can search for this string. It then leads us to this big function here, which resolves OpenGL functions. This is just a curio of OpenGL. You need to manually resolve all functions introduced after version 1.1 so that you get your driver-specific implementation. Anyway, if we rename some of these, we can start working our way through the code. Let's set a breakpoint on GL_get_integer_v, which we know is the last OpenGL call before we crash, and if we step through a bit, we can see that we crash at a function call here. This function seems to load a bunch of OpenGL stats and passes them into what looks like a log function. I can't see a log file anywhere being created, but stepping through, it does crash in the call to dump GL extensions, and if we dump the argument being passed in, it does look a lot like OpenGL extensions. To provide some clarification here, OpenGL is an API. It's a specification that graphics cards implement in order to provide a common interface to do rendering. The idea being that you write your game code once in OpenGL, and your graphics card will understand that and internally translate that into whatever internal platform-specific misery is needed. However, outside of the core OpenGL spec, there are also extensions, which your GPU vendor is free to implement or not implement. But if you're writing a game and you want to know what extensions are available to you on the current card, then you need to query for them. In this older version, you call GL_getString with the GL extensions argument, and that gives you a space-delimited string of all the extensions. When this is done in the game, it then uses a string copy-like function to copy into a global buffer, which we can assume is ox 1000 bytes in size based on the arg that's passed in. Okay, back to the crashing function. Let's step through it. This is insane. We can see here that there's a buffer overflow happening. The OpenGL extensions have smashed the stack and overwritten the return address. At a fundamental level, when a program calls a function, it has to somehow communicate to that function where to return to when it's done. This is done by pushing the return address onto the stack. When the function is done, it pops that return address from the stack and starts executing from it. The issue here is that some stack allocated buffer has overflown and overwritten that saved return address. So when the function ends, it tries to execute this garbage address. There's still so many questions. Well, there's two questions. Why is this happening, and why does it not happen on my host machine? For the former, we need to look at how this crashing function works. It first allocates space on the stack for ox 1000 bytes. It calls dunder alloc a under probe, but you don't need to worry about that. It's just a Windows mechanism for growing the stack by a large amount. It then calls this function, which if we step over in a debugger is some sort of vprintf, i.e. it's printing the args to a buffer, the stack allocated buffer. But if the extension buffer and the buffer being printed to are the same size, ox 1000, how does this overflow? Well, it doesn't take into account the fact that the format string itself, GL extensions %s, also occupies space, so when you write that, plus a fully filled extension buffer to the stack, it overflows. But why is this only a problem now? Well, the number of extensions has increased since 2001. Back then it was probably a safe assertion that the size of the OpenGL extension string would never exceed ox 1000, but in 2026 that's certainly not true. About 15 years ago, the source code for both Quake 3 and Return to Castle Wolfenstein were released, but if we dig through both of these, we can see that the Wolfenstein uses the vulnerable thisprintf, but Quake 3 uses the secure thisprintf, which checks for the size. There's a comment here from Timo in the Quake code that states the max size you can send to the printf function and says it gets truncated after that. Presumably this is Timothy Bissett, who wrote a lot of the Linux ports of id Software games. So Wolfenstein wasn't actually made by id Software, but by a company called Grey Matter Studios. They forked the Quake 3 code for their development. So how come they didn't get the bug fix? Well, I found the original version 1.0 vintage of Quake 3, grinded it through Ghidra, and found the same function. Here we are. As it was released in 1999, the bug is there. It's impossible to know for sure, but given that he wrote most of the core Quake 3 code, it could be Carmack's bug. This makes the second question even more intriguing. Why doesn't this crash on my host machine? Surely my 5060 Ti has at least as many, if not more, OpenGL extensions than my VM. Well, here's where it gets interesting. Setting a breakpoint on the code that gets the extensions, we actually get less than the VM, which seems strange. As we said before, a game needs to manually resolve the OpenGL functions to get the driver-specific implementation, and we can see here this ends up in the NVIDIA library nvogl32.dll. I suspect NVIDIA knows about this bug and are deliberately returning a subset of extensions to avoid the crash. In fact, if we rename the exe to something else, then we get the crash. Somewhere in the NVIDIA code there's a literal check against the exe name to load a profile to return safe data that doesn't crash the game. To fix this, my initial thoughts were to massage the assembly to increase the buffer size, but this proved brittle and caused crashing elsewhere. When patching, you really want to keep the changes as small and localized as possible because you are fundamentally altering the code at a very, very low level. So the easiest thing to do is just patch out the call entirely. It means some log somewhere doesn't get the full list of extensions, but I think we can live with that. To do the patching, I did the usual technique I do for a lot of these videos. I looked at all the libraries the game imports, selected one with a low number of imports, in this case winmm.dll, then created my own DLL with the same name and exports. This creates a DLL that, as far as the game is concerned, looks the same as the original. If we drop this in the game directory, then when it's launched, Windows will find my code and load it first, which then gives me an opportunity to execute my own code, in this case, patching the game. Let's go on a quick side quest, and please indulge me as I think you'll find this interesting. There's something deep inside me that just cannot ignore buffer overflow, so let's play around with this. We can use our custom DLL to hook glgetString and return a custom string. As is tradition, we will be returning all uppercase A's. So if we run this now, then we can see EIP, the instruction pointer, becomes OX41414141, with OX41 being the ASCII code for uppercase A. This means we can exert control over where the application is executing. Of course, out of all the A's we've smashed into the stack, we don't know which ones actually get loaded into EIP, and as I can't be bothered to do the pointer maths, we can cheat a bit. If we use this tool to generate a special pattern of characters, then overflow that into EIP, and copy EIP back into the tool, it will tell us the offset. Easy. So whatever we write at offset 4081 into our fake extension string will end up in EIP. We can confirm that by setting it to something else like ABCD. But who cares? It's still a crash. Well, we know the buffer these extension strings get copied into is a global buffer, which means we know the address, and we control the contents. So let's make two changes. First, let's force the return address to be in the global buffer, and second, let's fill the buffer with the byte OX90. This is a special 1-byte instruction in x86 which represents a no-op, i.e. it does nothing. OX90 is also the tag for our Discord, which you should definitely join if you're interested in this kind of stuff. So now when we run the game, we smash the stack, overwrite the return address with a buffer we control, and fill that buffer with nops. And look, we can step through it in a debugger and execute all these nops. This is incredibly powerful. We are now executing code we entirely control. The sky's the limit. So we do what everyone else does and find some dodgy shellcode from the internet. This looks like a C array of random bytes, but it actually represents real x86 instructions. We can slap this anywhere on our buffer, and now that we return into it, we first execute all these nops, affectionately known as a nop sled, and then we hit the shellcode. Let's just run this for reals. Pops calc, a classic example. This shows how dangerous a buffer overflow is. We exploited it to gain arbitrary code execution. Now, before all the hackers descend into the comments to point out the obvious, yes, this is very much contrived. I had to use a custom DLL to control the buffer, and if I can drop a DLL on your system, I've already won. But the point was to demonstrate how a buffer overflow could be exploited. Access is not the concern here. Also, modern Windows apps have many countermeasures for this simple kind of attack, such as ASLR and DEP, which are all disabled in this old game. Still, it was fun to smash the stack for fun and profit like it was the 90s. Anyway, that's one bug done, but can we do more? Well, according to PC Gaming Wiki, there's an unresolved issue where the game may crash when automatically loading after mission failed screen, and if we look through the Steam forums, the crash on start, which we've already addressed, and the crash on restart seems to be the two biggest issues of the vanilla game. The easiest way to trigger the mission failed screen is to die, and I've been running around and dying over and over again and only managed to trigger the bug twice. It's hugely non-deterministic and non-reproducible. But I did manage to finally trigger it under a debugger, and it crashes here, which if we relate to the source code is here. The code clearly checks if gentity is a null pointer before trying to dereference it, but in the crashing case it's not null pointer but a garbage address. This suggests some sort of use after free or incorrect cleanup. We are very lucky here that we have the source code because it makes this a lot easier. We can see that the client is from a global object, which allows us to basically grep for usages. There's still a lot of code to dig through, but if we look at the log output of the debugger, we can see something very interesting. When the level restarts, it unloads and reloads QA games x86.dll, which is a core library for these Quake 3 based games. However, normally it gets loaded back at the same address, which makes sense. A DLL can request to be loaded at a specific address, and Windows will attempt to honour this. However, that's not always the case, and when this doesn't happen is when it crashes. Also, when we crash, the bad EAX value is in the old library address, Curiouser and Curiouser. So I've dug through the source code a bit, and here's what I found. When the level reloads, it calls sv in its game VM. The game has a custom virtual machine, and this is what sets it up for a new game. This function issues a VM call to initialize a new game, and then clears all the clients by setting them to null. However, if we trace our way through the virtual machinery, we can see that this then calls gspawn entities from string, which then calls world spawn, which then calls our crashing function. So when you die and a new game starts, it must unload and load the library in order to reset state, but this library owns the game entities. Then, as part of its reinitialization, it calls this function to iterate through those entities, but it then cleans those up, but only after we've indirectly iterated through them. If the library comes back in exactly the same address, then that memory is valid and it's fine, which it will do most of the time. Presumably the data hanging off these pointers isn't valid, but at least the memory exists and the game seems to be okay with it. However, in the rare case that the library is loaded as a new address, the game now holds a pointer to invalid memory and it crashes. The fix is to clear the stale client entity pointers before we enumerate. The funny thing is that if we check back with the Quake 3 source code, then this has been fixed. It even has a link to an issue tracker which presumably covers this exact bug. I guess again, this was fixed after the devs took the Quake 3 code to work on Wolfenstein. We can force this bug by using our custom DLL to hook the Windows code for loading libraries. If it detects it's reloading QA games x86.dll, then we use virtual alloc to force a large allocation at the exact address the library will want to load at. This will prevent Windows reloading it at the same place as we've effectively reserved that address. And sure enough, it now crashes every time. The fix isn't too complex, it's just to replace the sv init game vm function with the equivalent asm that does the clear first, like the Quake 3 source code. And we can see it now works. I've removed the code that forces the crash, packaged it up and put it on GitHub. I've also had confirmation on Discord the patch worked. There's loads of fan-made remasters and updates which have done way more than I have, but it's nice to create a fix for the vanilla experience. This was fun, but there was another game that crashed when you tried to enter your name, and if you want to see how I fixed that, then check out this next video.